Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. Excuse me. My topic for this morning will be a long video format, and it's a continuation, excuse me, a continuation of my analytic geometry lesson, and we are now on lesson number 11. Okay, let's proceed. Excuse me. This is a continuation of my analytic geometry long video format topic, and we are now on lesson number 12. And the title of the topic will be Parabola, Vertex at the origin, axis is the y-axis, open downward. This is actually case number 2. Lesson number 11 and number 12 are actually the same. For lesson number 11, it's a parabola that opens upward. For lesson number 12, it's a parabola that opens downward. Their equations are actually almost the same, except that for case number 2, the one that opens downward, this should be a negative. There's a negative sign here. The significance of this negative sign is that the parabola actually opens downward. Okay, instead of upward, this is downward. Because for upward, this is plus. That was lesson number 11. We are just taking it easy, we are taking the different cases of parabola one at a time. So we will not be pressured into putting in our mind the concepts of a parabola. Okay? So for lesson number 11, this is plus, and for lesson number 12, this is minus. The different parts of the parabola for case number 1 and number 2 are actually the same. There is the so-called fixed line, which is termed to as directrix, and there is a fixed point designated by capital letter F, which is referred to as the focus. So for case number 1, which is lesson number 11, and case number 2, which is lesson number 12, directrix and focus are the same. Like what I said, the characteristics are actually the same. There is a fixed line and a fixed point. Okay? And by definition, a parabola is actually at any point on the parabola, the distance of any point from the fixed line and fixed point are actually the same. Like this one here. This is more accurate than from the previous lesson number 11. This point here, this distance here should be equal to this for it to be a parabola. And as the point moves, like if we move this point here, going here, again, if we try to measure the distance of this point from the fixed line, which is this, and from the fixed point, which is this length here should be equal to this. So it generates this point here. So the path of that will be this. Okay, supposing the point moves to this location here, our figure is not just actually as accurate as it can be. At this location, this distance here should be same as this one. This is longer, but it should be the same, right? Okay, that's the definition of a parabola. And at this location, this distance here should be equal to this. Our drawing is not to scale. This distance here should be equal to this. for it to be a parabola. On the other side, it's the same. If the point is at this location, this distance here should be equal to this. If the point is at this location, okay, this distance here should be equal to this. Its distance from the fixed line in the fixed point should always be the same as the point moves. And at this location here, it is not drawn to scale. This distance here should be equal to this. Okay? So if we try to connect all the points, okay, what will come out will be a parabola. Oh, that's case number 2. It's almost the same as for case number 1. The only difference is that the parabola opens downward. And there should be a negative sign here. So you must have to memorize this by heart. Okay? So you won't forget what's a parabola with vertex at 0, 0 at the origin. Okay? And its axis is parallel to the y-axis. Okay? Opening downwards. Opening downwards. So as soon as you see this equation here, x is equal to minus 4py, okay, supposing you are on the SAT or CAT exam, if they have given you this equation here, at least you now know that this is a parabola with vertex at 0, 0, axis parallel to the y-axis, opens downward. That's how we read this equation here. An equation of a parabola with vertex at 0, 0, axis parallel to the y-axis, meaning it's the vertical thing, right? And opens downward. That's this equation here. How x bar is, it's easy to visualize. Okay, I remove my glass. How x bar is, we'll bring out the equation. Okay. X is equal to minus 4py. If we place the value of y to be a positive value on this equation here, the overall sign, since this is with the negative sign, for whatever value of y that is plus, this will be minus. Right? But this is a square term. And if we try to take the square root of a negative value, I place it there, x do not exist. So meaning to say, at the location origin vertex equal to 0, 0, any value of y which is greater than 0, okay, the parabola does not exist for this equation. That's the meaning of this. Okay? But when y is negative, any value that is below the x-axis, meaning it's a negative value. Any value of y, okay, it should be negative 1, negative 2, negative 3, any negative value. If we try to place it here, okay, what will come out will be, since this is preceded by a negative sign, so if we try to place the value of y to be negative, what will come out for the overall sign will be plus. Right? So if it's a plus, if we try to compute for the value of x, okay, this should be a square root of a positive number. So what will come out will be a plus or minus. So the significance of this, for any value of y which is a negative value, there will be a left and right value. Okay? Like this one here, if we put the value of y here, this is the negative value, because the square root will be a negative, a plus and minus value, and this should be the other value. Okay, so as long as the value of y is negative, and if we try to plot the graph, there should be a left value and right value. The parabola is actually symmetrical with respect to the y-axis. Right? So when you place the value of y to be negative 4, what will come out will be something a plus or minus value. There will be a negative value on the left and a plus value on the right. So like what I said, the parabola is symmetrical with respect to the y-axis. That's the significance of how x varies. Oh, I think that's the only one that is very important here. For the distances, the distance of the vertex to the directrix is designated by letter P. And the distance of the vertex from the focus is also designated by letter P. Okay? This is true for case number 1, lesson number 11, and number 12. For the length of the lateral recta is this one, the latus rectum, this one. Okay? From this point here to the focus, it's 2p, and from focus to the other thing of the lateral recta is also 2p. So this value here is 2p, and this value 2p. This is p, and this is p. Oh, I think that's the only important thing in here. At least you know where the value p is coming from, and the value 2p, okay, actually also emanates, right? Okay, I would like to emphasize now the importance of the parabola and real life problems. This is true for electrical engineers, and this is being used in the so-called subcalculations. Subcalculations. Subcalculations of transmission lines. Like if we try to draw a two transmission tower number 1 and tower number 2, this is just an illustration. We assume that the ground is horizontal, assuming that the height of the first tower is the same as the height of second tower. And if we try to connect a transmission line, the one that supplies power to our houses, I just place a single line here, but in a study of electrical engineering, if I place 3 lines here, it's understood to be a 3-phase line. But for simplicity, since we are only illustrating a parabola as a figure, I would just place 1 line here. Okay? So if this is tower number 1 and this is tower number 2, and we connect to a transmission line between tower number 1 and number 2, this should be the transmission line. And under the study of electrical engineering, I think how the cable actually behave if it is suspended between 2 towers, it acts like a parabola. Okay? So this is now an application of the so-called parabola in real life. So when we say we hang a transmission line between tower number 1 and number 2, and they are at the same level, how the cable actually behave as it is being hung, okay, it behaves like a parabola. So for this one here, this is an example of lesson number 11, the parabola that opens upward. So it seems this is the so-called y-axis, and this is the x-axis. You got it? X-axis, y-axis. The lowest point on the transmission line is actually the vertex of the parabola. It seems it's this one, the reverse. Right? So it seems our vertex here is actually at 0, 0, something like that. Okay? You now know the importance of the parabola. This is the y-axis, this is the x-axis, this is the transmission line. Okay? The lowest point on the parabola is actually this point here, and that is referred to as the vertex. And for our lesson for tonight, this is we could place this one at 0, 0, something like that. And there are also problems in transmission lines in which the length of the transmission line is to be computed. Like if we know the distance between these 2 towers here, Okay, the project manager, maybe if you are the engineer for this one, he might ask you what will be the total length of the cable needed. Okay, if it is hung between two transmission towers, and which the distance between the two towers is maybe 200 feet maybe. What will be the total length of the cable needed? Okay, if we try to suspend a transmission line between these two transmission towers, he might ask you what will be the length of the transmission line. So this is where we bring out our knowledge of the so-called study of this is now integral calculus. Because if we know the equation of the curve, okay, ds is equal to, right, the square root of something like a dx quantity square plus dy quantity square. Okay, so if you know the equation of this one by using your knowledge of analytic geometry, and if you try to integrate this one, S now will be the total length of the transmission line. Okay, it's all calculus. Okay, that's it, guys. This is now the concept of lesson number 2. Okay, I just emphasized the importance of a parabola and real life problems. Okay, good morning from Los Angeles. This is Professor Rebecca.